What if everything you see, feel, and think is part of a highly advanced computer simulation? This isn't science fiction, it's a serious hypothesis debated by physicists, philosophers, and technologists. In 2003, philosopher Bostrom reframed the ancient question, "Is reality real?" into a logical trilemma with startling implications. Today, thanks to advances in quantum physics, cosmology, and computing, we can actually test parts of this idea. So, can we prove we're not living in a simulation? Bostrom's argument rests on three possibilities. At least one must be true. First, civilizations self-destruct before reaching post-human computing power. Second, advanced civilizations lose interest in running ancestor simulations. Third, we are almost certainly living in a simulation. Why? Because if even one civilization survives and runs thousands of high-fidelity simulations, simulated minds would vastly outnumber biological ones. Statistically, we'd be more likely to be among the simulated. But this isn't just probability, it's constrained by physical law. To simulate every particle in the observable universe down to the quantum level would require computational resources exceeding the energy and information capacity of the universe itself. So, any realistic simulation would need optimizations, like only rendering details when observed. Here's where science steps in. If spacetime is simulated on a discrete lattice, as many quantum gravity models suggest, there might be detectable artifacts. In 2012, physicist Silas Beane and colleagues proposed ultra-high-energy cosmic rays should interact with this underlying grid, causing direction-dependent energy cutoffs. We know such cutoffs exist, the GZK limit, but so far, they're isotropic, matching standard physics, not a simulated lattice. Other ideas: quantum indeterminacy could reflect computational economy, no need to compute unobserved states. Planck-scale discreteness might be the pixel size of reality. Yet, current experiments, like Fermilab's Holometer, have found no evidence of spacetime pixelation down to 10-18 meters. So far, reality behaves like base reality. Even if we are in a simulation, does it matter? If consciousness arises from complex information processing, as many neuroscientists believe, then simulated minds could be just as conscious as biological ones. Free will becomes trickier. In a deterministic program, choices might be illusions. But if the simulation includes true quantum randomness, or if it's a probabilistic emulator, agency could still emerge. Philosopher David Chalmers argues, if we're in a simulation, physics becomes computer science, but reality is no less real. The emotional weight, the suffering, the joy, they're all real within the system. The simulation hypothesis is elegant, logically coherent, and almost impossible to disprove. But science demands testability. Until we detect a glitch, a lattice artifact, or a fundamental limit that only makes sense in a simulated framework, it remains metaphysics dressed in math. And perhaps that's the point: whether base or simulated, this reality is the only one we have. Our duty isn't to escape it, but to understand it, protect it, and give it meaning. As physicist Sabine Hossenfelder puts it, the universe doesn't care if it's simulated. But we do, and that's what makes us real.